Section 10.2, question number 2. The type of household for the U.S. population and for a random sample of 411 households from a community in Montana are shown below. All right, so here's the type of household. We got married with children, married no children, single parent, one person. And here's a comparison now. Here's the percent of all the households in the U.S., and here's the number that we observe in this community in Montana. So in the U.S., 26% of all households in the U.S. are married with children. Now in Montana, in this one community, we observe 110. All right, so and so on. Now use a 5% level of significance to test the claim that the distribution of U.S. households fits the Dove Creek distribution. All right, so here's what it is for the U.S. Here's what it is for Dove Creek, Montana. Is there a match? Is it the same for Montana as it is for the entire country? Part A, what is the level of significance? Right there, 0.05. Now this question states a null and alternate hypothesis. Well, we're testing that, well, let's just look to see what they have. The distributions are the same. Alternate is they're the same. That doesn't make sense. They're both the same thing. The distributions are different. Now, we always test that they're the same. All right, you test that they're the same versus that they are different. All right, we're going to go with this one here. The distribution, the null hypothesis says the distributions are the same. The alternate says, no, they're not the same. They're different. Now, part B says, find the critical value of the chi-square. So we're looking for this value right here. We want chi-square star, and we can get that if we use the hypothesis test for goodness of fit. So let's go to our calculators. So stat, tests, as we normally do, but now you got to scroll down or scroll up to item D, where it says chi-square GOF, goodness of fit test. What we're looking to test is this. Do we have a good fit between what we observe and what we expect? Now, here's what we end up with. We get observed. I'll just do this. Observed, expected. All right, now I'm going to put these into lists. So I have to actually put my data into lists. I want that into list 1, this into list 2. So how do we get these lists? You're going to go to second, and then the numerical key 1, and then down here you go to second, numerical key 2, because right above you get L1 and L2. But we have to get those data into our list first. So before we do any of this stuff, let's go back, or we'll just get out of this. So for now, do a second mode, which is quit, because we want to put our data into lists. So let's get out of that. We'll come back to it momentarily after we have our data into our lists. So let's go to stat, and then number 1, where it says edit. All right, so we'll select stat and edit. Now, we probably have data in list 1 and list 2 from previous problems. So get your cursor in list 1. Put your cursor in list 1. Then use your up arrow and get your cursor right on L1. Right, so L1 will be highlighted. Then press clear on the right column and enter. And when you do that, all the data out of L1 will disappear. Now do the same thing to L2. Right arrow over to L2. You've got data in there. Get your cursor all the way up onto L2, so L2 is highlighted. Press clear and enter. Clear and enter, and all that data will disappear. Now get your cursor back into L1. Get your cursor back here into L1, because now we're going to start putting the data in. So what I'm going to put into L1 are the observed values. This is going to be our observations, and our observations are right here. All right, so we're just going to type those numbers in, so I'll read them. It's 110, 113, 31, enter, 90, enter, and 67, enter. Right, now down here at the bottom, L1 should be saying 6, because we have how many pieces of data? 1, 2, 3, 4, 5. All right, I got 5 pieces of data, so it's expecting number 6. So it looks like we're okay. Now, arrow over here, we're going to have to do a little bit of work for L2. Now for L2, all right, let's get it to right here. For L2, this is expected. Now the expected number is n times p. All right, so n, that's our number of observations, which is 411, right? How many people did we observe? 411. And p, this is going to be the percentage that we expect from the U.S. All right, so what we're looking at, like for the first one, these numbers here are going to come from this column. All right, so let me show you how to get this one right here. This is going to be, all right, so just type it in your calculator like this. 411, press the times key, and then put in the percentage, 0.26, right? Put it in as a decimal. Out of these, if these really match, if the observed values match the expected, then we should be seeing what, 20%, 26% of all 411 households. That's what we would expect. 26% of times 411. So down here, I'm going to put 0.26 and press enter. And when I did that, I got this 106.86. And it's automatically in there. So the calculator will do the computations for us. Now, in the next cell right here, right, the cursor is already there, so you're going to type in 411 times, all right, so let's see, let me get that here. So we're going to type in 411 times, and now the percentage that we're going to use is 0.29. So 0.29 will go here. And I'm getting 119.19. 119.19. Okay, I'll just go ahead and do the rest of them. These are the numbers I got when I finished it off. So these are the expected values. So here are the observed values in list 1. The expected values are in list 2. So what we expect here is that if Dove Creek, Montana fits this model, then these numbers should be not too far apart. They should be fairly close. We observed 110, we got 10, we expected 106. We observed 113, we expected 119, and so on. Now we're actually ready to run the chi-square test. So what are we going to do? We're going to run the test. So you're going to go to Stat, over to Tests, down to D, chi-square GOF, goodness of fit test. So Stats, over to Tests, scroll down to D, chi-square goodness of fit test. Now, the observed, those are going into list 1. So make sure you got list 1 there. So how do you get it? Second, and then numerical key 1. Enter, and then you get expected in list 2. All right, we just put those numbers into L1 and L2. And how do you get L2? Second, numerical key 2. Now we're ready to go. Now my calculator is also telling me the degrees of freedom is 4. And if you remember, degrees of freedom is the number of categories minus 1. So we have 1, 2, 3, 4, 5 categories minus 1 gives us that 4. Now go down to calculate. We're ready to go. And here's what I'm getting. I get my chi-square star value to be 13.468. Now they're asking us for that, right? Let's put that in while we're here. Right over here. Long ago, it seems. But that's what we're looking for. What is our chi-square value? Round to 2 decimal places. All right, so here's our chi-square. Calculator gave it for us. So if I go to 2 decimal places, I'm going to round up. So how about 13.47? All right, so this will be a 13.47. Now, are the expected frequencies greater than 5? If you remember our list 1, all those numbers were bigger than 5, so I'm going to claim this as yes. What sampling distribution will you use? Well, we're using a chi-square, of course, so that's going to be a chi-square. And then what are the degrees of freedom? Well, the degrees of freedom, 4. Then it asks us to find or estimate the p-value, round to 3 decimal places. Well, we've got the p-value is coming up on my calculator, and I'm getting this for p equals 0.0092, and so on. All right, what are we supposed to do with it? Down here, estimate the p-value, round to 3 decimal places. So if I round to 3 places, we're at 0.009. And a couple more questions here. Part D, based on your answers, will you reject or fail to reject? Okay, so that's where we're going to use our p-value. So I like to do that with a little table here. So here's my p, here's alpha. Now the p-value was 0.009, alpha was 0.05. So how does p compare to alpha? Well, p is less than alpha, and if you remember what that says to do, that says to reject H0. Now, which one of these corresponds to that? Since p is greater than alpha, well, it's not that one, it's not greater than. If p is less than or equal to alpha, we reject the null hypothesis. That is true, that's the one we're going to go with. Now, what is it that we're doing? We're rejecting the null hypothesis, and I just rewrote that up here. Null hypothesis is that the distributions are the same, so that the distribution in Dove Creek, Montana is the same as it is for the entire U.S. Well, we're rejecting that, so we're going to say that the distributions are different. So what have we got over here? At 05, the evidence is sufficient to conclude that the community household distribution does not fit the general U.S. That does not fit. I think that's what we're looking for. Otherwise, this one here says the distribution does fit. Well, that means it's the same model, and we're rejecting that. So we're going to go with this.